Hi everyone, welcome back to my channel. I'm Miriam. Today we are going to review word embeddings before jumping into any large language model or anything related to agentic AI. It's really important to know the basics and understand what's happening here, then we can move forward with more advanced projects. Let's get into this. In this video, we are diving into the world of text embeddings, which is a foundational concept in anything related to NLP, semantic search, AI applications like ChatGPT, or retrieval of information and documents. We will break down what embeddings are, how they work, and how to choose the right model for your use cases. So what are text embeddings? Text embeddings, they convert languages into numbers, specifically dense vectors in a high-dimensional space. Each sentence or document gets mapped into a vector that captures its meaning and concept. These vectors are what let machines understand relationship between different pieces of text. The main reason that embeddings are using vectors is that the functions that are being used to match the similarity are mathematical functional. So everything at the end goes back to numbers. So that's why we are mapping the sentences, the documents, and everything to a numerical value so we can use the mathematical functions such as cosine similarity to find the similarity between documents that are represented as numbers. Love cats or cats are great may not share keywords, but they are very close in embedding space, meaning they are talking about cats and how a person appreciate having cats, or they love cats in general. So that's how tools like semantic search, text clustering, or RAG work. Embeddings are being used in semantic search, document retrieval, clustering, any recommendation systems. Use them for the text classification and even duplicate detection and anything related to retrieval augmented generation. The embeddings are the bridge between any raw documents or text that we have and anything that machine learning and AI can understand. So let's talk about different embedding models that are in Python and were popular. Of course, nowadays everybody can use the OpenAI API, which is a cloud-based. You can just purchase the API or the membership for ChatGPT OpenAI and use the API for your Python coding and any experiment. The output dimension for it is 1536. The speed is very fast and the accuracy is really high, but you have to definitely be online to use it. You cannot download it and use it offline. And then we have, Universal Sentence Encoder from Google, which is one of the most powerful embeddings out there. And the speed is very moderate, but again, the pros of this embedding is that you can download it and use it offline. And then we have Hugging Face transformers in Python libraries, which is easy to implement and use in your coding. In this table, but let's dive into what are these output dimensions that we have for each of these embeddings. So these dimensions refer to how many numbers are in the vector. If you embed the sentence, let's say, I love cat, using any of these models, you will get different sizes based on the word embedding that you're using. And the length of the vector determines how much semantic detail it can encode. So the larger the dimension is, the better in semantic the results are going to be. But not necessarily we want better semantic all the time. There is always a trade-off. For example, smaller dimensions, they can bring you faster retrieval and they require lower memory. And they are perfect for fast search engines. Medium ones like BERT style, they're really great for general purpose NLPs. And the larger ones like OpenAI or anything that is about 1000, they give you deeper semantic and meaning, and they are ideal for complex Q&A or anything related to RAG models. Similar to anything else, there are some challenges in using embeddings, and they are not definitely perfect. For example, there is dimensionality trade-off. If the vector is too small, you lose meaning, and if it is too large, you need compute and memory. The next one is semantic drift that we see often. For example, the word bank can mean money or a river bank. Embedding sometimes miss the context, and that is really important to understand and consider. Then we have a specialized field. In law and medicine, we cannot use general embeddings like BERT because it's often going to fail, and we have to have domain-specific embeddings. Also, there is computational cost. Embedding millions of documents in a slow and OpenAI API, definitely the cost is going to add up fast. Storage is another concern. Large vector, they take space and they need efficient indexing, which we are going to discuss about indexing in the next episode. Then we have, not all the models support multiple languages, and there is a challenge for global applications. So still we are at the very early stages, I would say, in the word embedding and the world of semantic, that we want to generalize all these LLM models. And of course, bias is another major factor. Whatever data that you give to your embedding, that's the data that your embedding is going to use for context. So if it is biased, your embedding is going to be biased too. That is another challenge that is going on in the world of NLP, which is how to eliminate bias in our embeddings. One last tip that I'm going to share here, how to overcome these challenges, is that use contextual models like BERT for sentence level meaning. Elevate on real tasks, not just cosine similarity. Try to look at other similarity functions. Fine-tune the model and embeddings for your domain, and use multilingual models if it is possible, and if you need to support more than one language. And for scale, definitely indexing is really important. That's going to make the search efficient. We're going to talk about indexing. Indexing means that we want to organize a collection of embeddings or the vectors that we have from documents in a way that it makes it easier and faster to search. Imagine we have millions of documents. Like now that we are using ChatGPT, we want to learn how ChatGPT looks up for similar documents and brings the answer back to us. So that is related to how they have indexed all those documents and information that they have. That makes it easier and faster for ChatGPT to bring back the information. So we're gonna look into that indexing strategies. What is the best way to sort and store all these millions of documents, and what is the best way to search through them, and how different embeddings are using different indexing. Thank you so much for being with me and following me through this episode. Let me know if you have any questions in the comments, and I will see you in the next episode.